Calculus BC, we are looking at the 3.7 worksheet, and this is a really nice worksheet to get you some extra work. What I really want to point out for you is use your graphing calculator extensively. You don't need to take a derivative by hand on this worksheet. This worksheet is going to be way more conceptual, really testing your theory and your understanding of the material as opposed to really crunching numbers via derivatives by hand and so forth. So here's what I'm talking about. We're just going to do problem 1 together, but hopefully it's going to let you have a great idea on how to proceed with the rest of the worksheet. It says a particle moves along the x-axis, so we've got horizontal movement, right? This is a horizontal left to right movement. Its velocity is given to us as the opposite of t plus 1 times sine squared of t squared over 2. And they're saying for part A, find all the times t in the open interval from 0 to 3 when the particle changes direction. A couple of review issues here. We travel right when v is positive, right? We travel left when v is negative. So when you change direction, that means that you change from moving to the right to the left. It means that the sign of your velocity will change. You will change from positive to negative or vice versa. Inherent in that change means that as you change signs, you must have velocity equals 0. So, what you could do by hand is set that equal to 0, find out, every place where velocity could equal 0. You could even do a number line test and see when v changes from a positive to a negative and so forth. That's fine, except that the calculator can help you out so much more. Look, go to y equals and type this in, negative, and then, x plus 1. I'll say times sine squared. You're going to need parentheses around the sign and then raise it to the second power. Inside, I've got my x squared all over 2. Notice you can see way up here I do have that exponent of a second power. And by the way, you don't even really need your graphing calculator here. If you're really on your toes and really thinking, you could just logically answer part A if you know what you're doing. But we'll get to that in a moment. Look, your time, you can say between 0 and 3. Because they're saying on this interval from 0 to 3 seconds. My y min and y max, I decided to just try negative 3 and 3, knowing that sine itself is always between 1 and negative 1, and that t plus 1 can change. When you graph this, this is what your velocity curve is going to look like. And right now, just immediately as you look at this, it would appear that velocity is always non-positive. You could hit trace and get some help and see all these negative y values, right? And, even as you come over here, I think maybe what kids are most worried about is, this far right x-intercept up here. And so very often kids will wonder, well, could it actually be that this curve sneaks above the x-axis just a little bit? Look at your y values as you trace. They're negative, they're always negative. It does beg the question. Right now, if you were, trying to even get the x-intercept with the tool that we saw just the other video, second calculate, go to the 0 tool, you could find out what that x-intercept is. It does beg the question, how do you know for sure that really you don't sneak over that x-axis and v might become positive? Think about it this way. When you have t between 0 and 3, I hope you can see that right here, this t plus 1 is always going to be a positive value, and you've got your negative out in front of that. Sine squared is going to be non-negative. It's always positive or 0, right? So just looking at all those signs, you can know for sure that it's impossible to get this multiplication of the negative and this parenthesis and the sign to become positive. It just cannot happen. So can we ever get velocity to turn into something positive? No. Find all the times when it changes direction. It never changes direction. Now I'm going to bring the calculator back up just for a moment, just to point something out. You know, when you're graphing, if your curve would have gone above that x-axis, then you can see that, velocity is positive and you're turning to the right, you're traveling to the right. Let the calculator help you in that regard. You can use the 0 tool to find where your velocity is 0 and where your particle is stopped. But I hope that's going to help you out abundantly. Acceleration, so very often kids will say, well, I did this problem and I used the product rule and I really crunched this out and then I plugged in t equals 2 and, is that okay? You may do it, but let me show you a much easier way to do it. Such an easier way. Sorry, I made this screen get a little bit bigger. Look, something I want to show you guys is the derivative is under the math menu. Here's math. If you just down arrow to number 8, you can see D, and I'm going to hit X. Right here is where you could type in that formula of negative x plus 1 sine squared of t squared over, or x squared over 2. That would take a lot of work, and you just entered it in. Please pay attention. Go to vars. Look at the down arrow. You can see my cursor's floating over that. Right by the down arrow is vars. I'm going to press vars. Then I want to go to y vars. So I'm going to hit the right arrow. I want to hit function, hit enter, then hit y1. Look at that. Take the derivative of what you typed in for y1, plug in a 2, and look at that. It's 3.713 or 3.714. So that's what your acceleration is pretty close to equaling. Well, what about v of 2? Look, at v of 2, if I did vars, y vars, function, look at this. Just like with function notation, we can just put parentheses around it. You'll get negative 2.480. So velocity is negative. We already knew that. We knew that from what I talked about in part A, velocity is always negative. We saw our acceleration was going to be positive. So is the speed increasing? Are we speeding up? No. You could say, no, the particle is slowing down. Or how about you can just answer the question directly. The speed is not increasing. You're actually slowing down. If you wrote slowing down, that's fine, because A of 2 is positive and V of 2 is negative. You're effectively saying that these two have opposite signs. So as long as you have opposite signs, you're slowing down. Your speed is actually decreasing. If acceleration and velocity both have the same sign, either both positive, both negative, then you're speeding up. That means that your speed increases. Hope all is going well. Finish the worksheet up. Use your calculator to help you take derivatives and to get help graphing.